All right, so let's do another example of our parallel lines cut by a transversal. In this particular problem, I'm asking you to find the measure of all 10 of these extra angles here. And it gives you two different little facts. It says that this angle here is 89 degrees, and this angle here is 114. All right, so my favorite set of angles is vertical angles, which I call bow tie angles. So that means that these two angles right here are equal because they make a bow tie. Like you could make yourself a little bow tie right here out of these if you wanted to. Okay, so these two are equal. This one's a really wide bow tie, but these two here would also be equal. Okay, so let me take my markings off. This first one right here is 89 degrees, so that means angle 1 is also 89 degrees. And this one here is 114 degrees, which means angle 6 would also be 114 degrees. Okay, because vertical angles are equal. Now, then you can just start wherever you want and just start filling in the blanks. Okay, here's how I do it. I go to what's the easiest for me to visually see. Okay, so the next thing that's easiest for me to visually see is that this whole set right here is a straight line, and a straight line makes 180 degrees. So if this piece right here is 114, then this piece here is supplementary. So we could say 180 minus 114, and that's going to give us our value for 8. Now I brought in my calculator with me. Remember, you get to use a calculator on your test. So I'm going to have that angle 8 is 66 degrees. Now, you can also look at angle 8 here and angle 7 here. Those are bow tie angles. So if angle 8 is 66 degrees, so is angle 7. Okay, and that's how those would work. Now then, let's see what else we got. That finishes up that bottom little quad there. Now, we have another little rule that says that alternate interior angles are equal. Okay, so those are the interior. If you made a Z out of it, of course this is a backwards Z, but alternate interior angles are equal. So that means angle 5 and angle 7 are equal. So 5 and 7 are equal. That means that angle 5 is 66 degrees. And that's again because they make this little shape and they're both interior. Okay, so that's our next little group. Now remember, I just said that angle 5 is 66 degrees, so I'm going to write that right there. Okay, when I look at this red line here, remember that's a straight angle, and a straight angle is 180 degrees. So if I'm looking for angle 4, I'm going to take 180 degrees minus 89 degrees minus 66 degrees, and this is going to give me the measure of angle 4. Which is going to be 25 degrees. Because remember, these three angles right here have to total 180 degrees. All right, so that's that part. Let's keep working with that. I'm going to pick a different color, and let's take this blue line right here, which was really already blue. Sorry about that. All right, so this blue line right here also makes 180 degrees. So this is going to help me with angle 3. Okay. Now, there might be another way to do, as I look at it, there's another way to do angle 3. So you have multiple ways to get to the same answer. But looking at this blue line, I know it's 180 degrees. So I'm going to have angle 3, which I don't know yet. And then I'm going to have 89 degrees. And then I'm going to have 25 degrees. So if I said 180 minus 89 minus 25, I'm going to get 66 degrees for angle 3. You also notice that it was a vertical angle from earlier. Right? So let's talk about the vertical angles. See angle 2 right here that makes this shape? It's going to be a vertical angle. Remember I called it a bow tie angle? it's going to be a bow tie angle with 25 degrees. So angle 2 is going to be 25 degrees. Now I'm going to erase my markings. In this top little piece, you had 1, 2, 3, 4, and 5. I have all of those. We have 6, 7, and 8. I have all of those. So all that's left are 9 and 10. Okay, so remember, I have something called alternate interior angles. So this angle right here and this angle right here are equal. They're alternate interior, which means they're on the interior side of the parallel lines, and alternate means they're on opposite sides of the transversal. So that means that 89 and 9 are equal. Because that's how it showed. And then also remember that 9 and 10 form vertical angles. They make a bow tie. So those are also equal. All right, so my answers are on the following slide. 89, 25, 66. 25, 66, 114. 66, 66, 89, 89. Great. Just wanted to put it in there to double check them. Okay, so there's another little rule that you have. All right, so we're going to move on to a different task here, and that task is naming polygons. And so polygons are your shapes. If it has 3 sides, it's called a triangle. A quadrilateral has 4 sides. And of course, they're different types here. So a rectangle is a type of quadrilateral, a square, a trapezoid. Any 4-sided shape is called a quadrilateral. A pentagon has 5, hexagon has 6, heptagon has 7, octagon's your stop sign, right? Nonagon, decagon has 10, hendecagon 11, dodecagon has 12, and so forth. Now, I'm not going to ask you all of those, but on a test, I would ask you possibly one of these. Now, these are all good down here, but I never go past the stop sign. So make sure that you know if I ask you, what is this shape? You know it's a quadrilateral. If I said, what's a stop sign? You know it's an octagon. Okay, so here's an example of a pentagon. It has 5 shapes, and a pentagon has 5 sides, and a hexagon has 6 sides. And this shows you some examples of one. If all sides and all angles are congruent or equal, they are called regular. So a regular polygon has equilateral and equiangular, which means all sides are equal and all angles are equal. Now, if all sides are equal and all angles are equal, you can find the measures of the interior angles of these shapes. But you have a rule that says the sum of a measure of the interior angles of any n-gon or any polygon is n minus 2 times 180. Okay, and that's a little formula you'll need to know. So I asked you 2 different questions right here. I said, I didn't put any questions in there, but let's say that I asked you to find x in both of these. Okay, so in this first one, there's 1, 2, 3, 4, 5, 6, 7 angles. Let's count our sides. 1 side, 2, 3, 4, 5, 6, 7. Okay, so this one has 7 sides. So I know that in a 7-sided figure, 7 minus 2 times 180. So remember my formula that I used earlier, n minus 2 times 180? Okay, so if I said 7 minus 2, that's 5 times 180. I get 900 degrees. So this figure right here has 900 degrees. So we're going to go through there and add up the sides. So we could say 123 plus 131 plus 121 plus 126 plus 139 plus 138. All of those plus x have to equal 900 degrees. So 123, 131, 121, 126, 139, and 138 total 778 degrees. So 778 degrees plus x would equal 900. So I could subtract 778 from both sides. And I'm going to get that my missing side right here is 122 degrees. Okay, remember you can use a calculator on your test, but it has to be one of the allowed types. All right, so in my second example, it gives you a hexagon, I believe. Let's count them up. 1, 2, 3, 4, 5, 6 sides. Yes, so a hexagon has 6 sides. So we use our formula, n, 6 sides, minus 2 times 180. So that would be 4 times 180. That means that all of these interior angles of this hexagon here have to total 720 degrees. Okay, so let's go around. We have 2x plus 11x plus 11x plus 11x plus 11x plus 2x would equal 720. Let me double check them. 2, 1, 1, 1, 1, 4 of those. 4 11x's and 1 2x. All right, so if we add up all of our x's, we have 2 plus 11, 11, 11, 11, and 2. So that's going to give us 48x. Okay, so to solve that out, we divide both sides by 48. And we get that x is 15. So in this value, x was 15. And that's how it would work. The main thing to remember about this particular one is your formula is an n minus 2 times 180, and that's going to give you how many degrees are inside that shape. Okay, so I threw in an extra complementary and supplementary because there was one like this in the homework. This particular one I know is supplementary because remember, a supplementary angle makes a straight line. Supplementary also means that it's equal to 180 degrees. So if I take 5x plus 18 as my left angle and I add it to x as my right angle, I'm going to get 180. So solving the equation, 5x plus 1x is 6x plus 18 equals 180. So I'm going to get that 6x equals 162. I'm going to divide both sides by 6. And x is 27. Now, sometimes it'll say, what is x? But I believe in your homework, it asks you to tell me what are both angles. Okay, so that means this angle right here is 27 degrees. So x is 27 degrees. But we also have to find the other angle. So remember, if x is 27 degrees, it's going to look like this. 5 times 27 plus 18 would mean my other angle is 153 degrees because 5 times 27 is 135 plus 18 would give me 153. All right, so the next thing we have are polyhedrons, and I won't ask you any of these on your test, not your midterm at least. I might ask you a couple of questions with it on the quiz though, but it makes for a really good hands-on example for your students. And so it's called a polyhedron, which means it's a three-dimensional shape. And so if you make a three-dimensional shape, it looks like this. So you've got a tetrahedron, a cube, an octahedron, which means it has 8 faces. And so what a face is called, if you take these three-dimensional shapes, this little piece right here is called a face. So an octahedron has 8 faces. Now, if you took these three-dimensional shapes and you kind of sliced on an edge, it makes something called a net. And a net is a pattern. If you took this and you put it on dotted lines and you fold it along the dotted lines, it's going to make your three-dimensional shapes. And so I give you a discussion board on this and ask you about using these nets to fold them up and make three-dimensional shapes in your classroom. So that's how I'll ask you this particular example. That's it.